my name is minteq. So today I would like to complete this question, which is about Redox Simulation by using Visual minteq. So first of all, I will open my Visual minteq, and I am opening Visual minteq 3.0 here. So we will go back to our question number 1. By using Visual minteq and determine the redox potential of the redox couple HS- and SO4-2 at pH 4 and ionic strength of 0.00. So we go back to our Visual minteq, and at pH we choose fixed at, which is the fixed at 4, the pH, and then the ionic strength will be 0.00. So the component is, first is HS-1 with total concentration 0.001 at 2 Lis, and another one is SO4-2 with the total concentration is the same and at 2 Lis, and we need to go to view or edit list to make sure that everything is in correct component name, total concentration. And next we will go back to main menu, and we go to redox, specify redox couples, and then our redox couple will be HS- and SO4-2 and add. And it has been stated here that the Visual minteq will assume a fixed PE value of 11. To change the settings, go to the specify PE or EH menu. Okay, so we go back to main menu and go to parameters, specify PE and EH. We choose PE or EH compute, supply a gas for EH, and I will put here 50. Save and back to main menu, and then after that we will run our minteq. So this is for question number 1, which is the equilibrium PE is 0.118 and the EH is 7. So for question number 2, we will go back to input menu. Without go to reset or anything, we will just continue. Okay, so we will go back to our question, which is by using Visual minteq and multi-sweep to stimulate what happened to 1 gram of mechanite when the pH changed from 4 to 13 at a redox potential of -236 MV, and allow for ferrihydride to precipitate, and plot a graph that shows the concentration of dissolved Fe+2, Fe+3, HS-1, SO4-2 and H2S aqueous versus pH. So we will go back to our Visual minteq, and we go to our parameters, specify PE and EH. We choose fixed EH, which is based on the equation. The fixed EH will be -236, and then save and back to main menu. And then next we go to solid phases and exclude species, and we choose specify finite solid phases. And then first is mechanite. Okay, so the amount of solid, we know that the mass is 1 gram, so what we need to know is the molecular weight. So the molecular weight for mechanite is 85.42. So I had been calculated 1 divided by the molecular weight, so the results is 0.0117 mole. So I will put here 0.0117 mole, 0.0117 mole, and add back to main menu, and then we choose solid phases and exclude species again, and we choose specify possible solid phases, and then we choose ferrihydride. So we choose add here and back to main menu. So next step is we go to problem and sweep. Okay, so what we do is, here is we take this sweep, one parameter is varied, and the start value is at 4, and the increment between the values will be 0.5, and then here will be 19. So how do I get this 19 is because the starting value is 4 and the increment value is 0.5. So 4 until 13, the numbers of problems will be 19 here. So the component here will be, first is Fe+2 total dissolve at Fe+3 total dissolved at HS minus 1, total dissolved at SO4 minus 2, total dissolved at, and the last one is H2S aqueous concentration at. So after we complete this component, we will go to save and back, and then we run our minteq. So after we run our minteq, this is for question number 2. The equilibrium PE is negative 3.989 and the EH is negative 236.00. So what we do here is we choose selected sweep results and we choose print to Excel, and then we go to Excel. Okay, so what we do here is we change the position first, which is like this. Then we go back here, we put it here, and this one we will put it here. So we will make this table look nice here. So so after that we highlight for pH here until the concentration. Okay, so we will insert and we choose scattered graph and we choose the first one, and then we need to make sure that this graph in the professional format, which is we will delete this one. Okay, so what we do here is we change here first, which is at axis options we will choose logarithm scale, which is here we choose axis value is 1.0 E negative 30, and same goes to here. At the bounds the minimum is 1.0 E negative 30. Okay, 1.0 E negative 30. So next is here. Okay, we will go to our format. Okay, for tick marks outside we will choose outside, and the line will be solid line, black color, and then here also black, and then same goes here. We will choose the tick marks is outside, solid line, black color, and here also black color. And next we will do here, which is the legend. Okay, so we go here and black color also. So the border, okay, the border will be no line. Okay, so I will choose here, wait for a while, the grid line, so I can see the graph better. So I make sure that this one I will make it bigger. So here I will choose the axis titles, which is it would be the total dissolved solid, which is M, and then this one also black color. And then next is pH, which is pH. pH, oh sorry, pH. Okay, so black color, this one also in black color. Okay, so the title here will be the total dissolved solid versus pH. So this one also will change to black color. So this is our final graph for total dissolved solid versus pH. So that's all from me. Thank you.